Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
So this is another example where we have to balance this reaction. So the reaction. So to balance the reaction, we have to determine the number of atoms which are present rather than the oxygen, rather than the hydrogen are present in balanced form or not. What I am going to say is, or what I'm trying to say is, let us see whether the other atoms rather than hydrogen and oxygen are balanced or not. So now in this case, we are not going to observe recently about hydrogen and oxygen. We are now going to observe for non-hydrogen and non-oxygen. That is, in this case, is chromium. So as we can see, the chromium which is present on the reactant side is 2. The number of chromium atoms are 2, while in that of the number of chromium atoms on the product side is only 1 time. So therefore we have to balance this thing first itself, because in the second or in the next step we are going to balance the oxygen as well as hydrogen. So we don't need to mention the balancing of oxygen and hydrogen within the first step only. So first step in this case would be balancing the chromium one. So I could name this as step number 1 as balancing the chromium atoms. So I could balance it by multiplying 2 on the product side. So the answer, or the overall answer, that equation that I could get is now being changed to H2O2 plus Cr2O7 2 minus, that should give me O2 plus 2 times that of Cr3 plus. So in this case the chromium is being balanced. So the next step will be the same as the earlier one, that we have to calculate, or we have to determine the oxidation number of chromium and the atoms present in the reactant side as well as in the product side. So let us name the step number 2 as determination of oxidation number. So for step number 2, I will write it as determination of oxidation number. So first what we are going to do is, we are going to determine the oxidation number of, in this case, for oxygen. Why? Because as we can see in the left hand side, that is hydrogen peroxide is present, and on the right hand side, that is on the product side, O2 is been present. So because there is a common thing of oxygen atoms present in the reactant side and in the product side, so we are going to determine the oxidation state of oxygen in H2O2. So how could we write that? So the oxidation number of H2O2, or the charge present on the H2O2, is 0. Therefore 2 times that of hydrogen which is present in a hydrogen peroxide plus 2 times that of present of oxygen atoms will make an overall charge as 0. But since we are going to find, or we are going to determine the oxidation number of oxygen, we will take the oxidation number of oxygen as X. But for hydrogen we know the oxidation number, that is 2 into 1 in this case, plus 2 into X, which is overall 0. Therefore 2 plus 2x, which is 0. Therefore 2x is nothing but minus 2, and x is nothing but minus 1 in this case. So therefore, ultimately we have evaluated or we have mentioned the oxygen. So we have mentioned the oxidation state of oxygen as -1 in H2O2. So therefore, we have made a statement that the oxidation number of oxygen in H2O2 is 1 minus. Now what we are going to do is we are going to determine the oxidation number of the next reactant, and in this case the next reactant is chromium oxide, that is Cr2O7 2 minus. In this case we have to calculate the oxidation number of chromium. So how can we calculate? We could take it as directly, or we could write it as the oxidation number of Cr2O7 2 minus is 2 minus, means the overall charge present on this molecule is 2 minus. So therefore the number of atoms which are present are 2 into chromium plus 7 into oxygen, and which gives an overall charge present on the molecule as -2 or 2 minus. So for chromium we don't know, so I could take the value of chromium's oxidation number as X plus 7 into the oxidation number of oxygen in this case is -2, which will give an answer of 2x, which is equals to -2, 7 into -2, which is -14, and if that goes to the right hand side it will become +14. So therefore 14 minus 2 is nothing but 12. So x will be 12 divided by 2, therefore x is equals to 6. So this value that we have got, it is for chromium present in the Cr2O7 2 minus, means the oxidation number of chromium in this molecule will be 6 plus. So therefore I will write a statement as the oxidation number of chromium in Cr2O7 2 minus is 6 plus. So let us find it out for the product also. So in this case the product was O2, and in this case the oxygen state of oxygen can be calculated as 0. Why? We can do it that the oxidation number of O2 is 0. Therefore 2 into oxy will be overall give a charge, or will overall give an oxidation number of 0. I could consider the oxidation state of oxygen as X, so therefore 2x is equals to 0, therefore x is equals to 0 divided by 2, that is 0 itself. So in this case the oxidation number of oxygen is 0. I could write the statement also, the oxidation number of oxygen in O2 is 0. So the oxidation number of the product, that is the next product, that is Cr3 plus, is also being mentioned in the reaction. So we could write the oxidation number of Cr3 plus directly as 3 plus. Therefore the oxidation number of chromium in Cr3 plus is 3 plus. So this is how we have calculated the oxidation number of reactant atoms as well as for the product atoms also. So now we are going to do the next step, that is we are going to balancing it by electrons. But let us see whether the reaction is a redox reaction or not. So how can we do? We could write the overall reaction in this way. That is H2O2 plus Cr2O7 2 minus, that should give us O2 plus 2 times that of Cr3 plus. So in this case, the oxidation number of oxygen was found to be 1 minus, while that of chromium was found to be 6 plus, while that of oxygen it was found to be 0, and that of chromium in this case, that is in 2 moles of Cr3 plus, was found to be 3 plus. So in this case, as we can see, the oxidation number of oxygen in H2O2 is 1 minus, which is converting into 0, which means the electron are being lost by the oxygen H2O2 molecule, and hence it has converted the oxidation number of oxygen as 0. So because electron has been lost, so therefore this is an oxidation process. And while viewing or while observing the oxidation number of chromium, we can see the chromium, which has initially in the reactant side as an oxidation number of 6 plus, is being converted into oxidation number of 3 plus. This is only possible if 6 positive charge will accept 3 electrons. So because in this case the electrons are being accepted, then only it has converted into 3 plus. So therefore the process in which electron is being gained or is being accepted is known as reduction. So by the help of this, we have confirmed that the given unbalanced reaction is basically a redox reaction. But the second step which we going to do is balancing the electrons. So let us see how can we balance it. So for that, I would write the step number 3 as balancing electrons. So the last reaction that we have did, or the last equation that we have did recently in step number 2 was this one. In this case, the H2O2 molecule, which had an oxidation number of, in case of oxygen, was 1 minus, it was being converted into 0. So therefore the electrons are being lost. That's the reason it is been called as oxidation. So therefore the number of electron has been lost. So to convert -1 to 0 means you have eliminated 1 electron. So therefore number of electron lost during oxidation process, basically in this process, was 1. Now let us see how many number of electrons were being gained during reduction. So therefore the number of electrons gained during reduction will be, in this case, as we can see, the charge which is present on the chromium, that is the oxidation number of chromium, is being converted from 6 plus to 3 plus. This is only possible if chromium would have been gained 3 electrons. If it has gained 3 electrons, then only it has converted its oxidation number of +6 to 3 plus. So the number of electrons gained are 3 in the reduction process. So this is what we have got. But as we can observe that the number of electrons lost during oxidation and the number of electrons gained during reduction, the both are not same. One has a value of 1 while the other has a value of 3. So they are not electronically balanced. So what we are going to do is, we'll do a simple process that is known as cross multiplication. So what we are going to do is, we'll multiply 1 by 3. and this 3 by 1. This implies that wherever the oxidation process is been occurring, we have to multiply that process by 3, and the molecule which is showing reduction, we have to multiply that by 1. So the recent equation that we have balanced was this one. So what we are going to do is, for oxidation, as we have written, we will multiply it by 3, and for reduction we will multiply and for reduction we will multiply it by 1. So therefore, wherever I could see the oxidation process, I should multiply it by 3. So therefore 3 should be multiplied here. If 3 is multiplying here, so therefore in the product side also the 3 will be multiplied. So the overall reaction that we have got by balancing the electrons will be, I will refer this as the new equation that has been balanced. So because of help of this, I could balance the next one, that is, I will balance electronically, or I will balance with the number of electrons in this reaction. So I could get 3 times of H2O2 plus Cr2O7 2 minus, that will give us, again because I am multiplying it on oxidation side, so if this is been oxidized to O2, so therefore it will also be 3 times O2 plus the answer that I have got was Cr3 plus, or the product that I got was 2 times Cr3 plus. So now this equation is balanced with electrons. So now next what we are going to do? Yes, now we are going to determine that how many number of oxygen atoms are present on the left hand side, and how many number of oxygen which are present on the right hand side. So the step number 4 will be, yes, it will be balancing oxygen atoms. So our recent balanced equation that we have calculated was in step number 3. So in this case, what we are going to do, we are going to calculate we are going to determine how many number of atoms are present on left hand side. In this case, for H2O2, for 1 mole of H2O2, the number of oxygen atoms is 2, but for 3 moles it will be 6, and for chromium Cr2O7 it is 7 number of oxygen atoms are present on Cr2O7. So therefore the overall 6 on H2O2 plus the overall 7 oxygen atom, it will give an answer of 13. So I could write it as the number of oxygen atoms on left hand side or on the reactant side, which is 13, and the number of oxygen. So now we are going to calculate the number of oxygen atoms present on right hand side or present on the product side. So we have got a value that we are going to calculate as 3 times of O2, means oxygen has 2 atoms of oxygen atoms, means oxygen molecule has 2 atoms of oxygen atoms, which means there is overall 6 oxygen atom present in 3 moles of O2. So therefore I could write it as 6 times the atom of oxygen is present on the right hand side. But as we can see, the number of oxygen on left hand side, which is 13, is not balanced with number of oxygen which is present on right hand side. So what we are going to do? Now we are going to determine that where is the deficiency of oxygen. It has been clearly mentioned in this screen, that is, there is deficiency on the right hand side, or there is deficiency on the product side. And how many? There is a deficiency of 7 oxygen atoms on the right hand side. So therefore what we are going to do is, now we are going to add 7 times H2O. I will tell it again why we are adding H2O, because H2O, that is water, it acts like acid also, as well as it acts like base also. So therefore it is basically neutral, as we could say. So therefore we will add 7 times H2O on right hand side. Therefore what we could get? We could get it as, the equation that we have recently balanced was this one. Now we are going to add 7 times H2O on the right hand side. So therefore the answer would be 3 times H2O2 plus Cr2O7 2 minus, that should give us 3 times O2 plus 2 times Cr3 plus 7 times H2O. So this is what we have balanced the oxygen atoms. And the last step is remaining, that we have to balance the hydrogen atom. So we will consider this as the balanced one, not the previous equation that we have balanced. So this is the recent thing that we have balanced. So in this case there will be step number 5, which will be named as balancing hydrogen atoms. So the number of hydrogen atoms on LHS, or left hand side, is, let us calculate. For H2 there is, for H2O2 there is 2 hydrogen atoms, but for 3 moles of H2O2 there will be 6 hydrogen atoms. So therefore I could write it as the number of hydrogen atoms on left hand side is 6, while the number of hydrogen atoms on right hand side will be, let us see it again, there is 7 times H2, which means there is 14 times H atom, hydrogen atom present on the right hand side. Again, if we observe this thing, so we can observe that the number of hydrogen atoms are deficient on the left hand side, or are deficient on the reactant side. So there is a deficiency of around, we could say, 8 atoms of hydrogen which are present, which are not present on the left hand side. So we are going to add 8 moles of H plus on the left hand side. So therefore adding 8 times H plus on the left hand side, we get the recent equation that we have balanced was this one. So what we are going to do is, we are going to add the H plus ions on the reactant side, and this again I would say H plus ions means we are making it in a acidic medium. So therefore what we are going to do, we'll take the reference of this equation and we'll going to balance it. So therefore the overall reaction that we have got is 3 times H2O2 plus Cr2O7 2 minus plus 8 times of H plus on left hand side. That should give us an answer of 3 times O2 plus 2 times Cr3 plus, chromium 3 plus ion, plus 7 times H2. So in this case, let us see whether the atoms are being balanced or not. Again, as we could see that chromium is being balanced according to the atoms, number of atoms. The hydrogen atoms are also being balanced here. And the next thing is oxygen are also balanced, and yes, we have balanced the electrons also. So this is how we have balanced and unbalanced reaction by using the oxidation number method in acidic medium. So I would mark it. Such a long step to do this reaction, but it is very much easy, and it will be very much influential in your exam point of view also. So thank you friends for watching this video. I hope you have liked this video and you have got a new concept how to balance the reaction initially when we see whether the compound or whether the molecule is not hydrogen or not oxygen. We have to balance it first. So this is the precaution that we have to take initially itself. Otherwise the reaction or the balancing this thing would get interrupted with mistakes. So I hope you have understood this thing. So please share this video with your friends and don't forget to subscribe Ekeeda channel. Thank you so much.